Let hello, hello, friends. Uh, Good afternoon. Welcome to the session today on Calculus Part 1. So, this is basically taken for the sake of IIMB UG entrance examination, which is being conducted this year on December 13th, as you people are mostly aware of it. And this is also helpful for the people who are planning to appear for IPMAT Indore or Rohtak or so, let's say, in which they can ask questions on limits, derivatives, continuity, differentiability, and application of this part. This all comes under the differential calculus, to be more precise, and there will be another part of integral calculus as well. So basically today we will we'll try our best today in this 1.5 hour session to cover what all are possible. Let's say, like, I would be definitely covering limits, derivatives, and application part by taking few questions on it. I hope I'm pretty much audible. If there is any issue, you can please let us know on the chat box. And while I am taking up the session, you are most welcome to take any doubt or to ask any doubt, whichever you feel in the spot of, like, answer solving method or conceptual clarity, whatever it could be. You could just post it on the chat box so that I would be able to read it and uh, discuss about your particular query. So, for meanwhile, I'll just put my phone aside. Let us start this topic of calculus. So, when I talk about this, precisely when I talk about this IIMB UG, I mean the IIMB UG test, this is the very first time Bangalore is conducting this undergraduate entrance test where people are given admits to IIM Bangalore for their UG program for bachelor's in economics or bachelor's in data science. Like, one is major and the other is minor, so both departments is what they're maintaining this year. So this is a good opportunity, I would indeed say, for the people who are aspiring to be one among the top people of the country, let's say, because IIM Bangalore is obviously one of the top institutes of our country. So doing undergraduation there is definitely highly recognizable and worth it all for sure. So for that purpose, we have curated 5 free mock tests for this year's IIM Bangalore UG test, which is on December 13 being conducted by the IIM Bangalore. This particular test is curated or framed by alumni of IIM ABC who are pretty much aware of how the paper is going to look like, and we have ensured to include arithmetic, algebra, and the topics whichever could be the part of your test. And let me tell you before saying that these are very high quality marks in the very first place. Having said that, one more thing which we have to take into consideration is that there is no clear clarity on exactly the composition or the difficulty level of the original December 13th exam, how it's going to look like, because this is the very first time they're conducting. I hope so they are going to release a sample paper in the December first week, if I'm not wrong. So in that during that time we would get more clarity on it. Then we will update this as per the requirement, and you should definitely give this to assess yourself better. So where do you stand and where do you lag behind, what are the topics you're good at or weak, so that you can plan your exam preparation for the next few days in such a way that you work on your weaker areas, and parallelly you should be ensuring to score maximum marks in your strength areas. So that is one thing. And the other point is that we are having this WhatsApp channel for IIMB UG, which the link is in the description of this YouTube session. So this is pretty much like this is, I would say, this is the place where you will be getting all the updates, or any doubts you have you could definitely post it on that and our team will reply to it. And myself and everyone else, like educators, everyone are the part of that group. So any subject doubts, or let's say any exam related doubts, how's the application and what's going on exactly with this, that will be a good channel, that will be a good platform for you people to definitely take part into and get your doubts cleared and practice as well. They will be posting some practice study. There is a study room, obviously a separate study room is created for IIM Bangalore. Should definitely make use of it for the practice. So let us start with limits. So what is basically a limit in the calculus? See, the reason why we are taking up this is it is clearly mentioned on the IIM Bangalore FAQ portal. The syllabus for this particular exam is NCERT 11-12. So NCERT 11-12 obviously does contain continuity, differentiability, these all things. So limits, starting with the limits calculus part. So basically it is denoted in this way, where we say limit x tends to a f of x. This is how they basically represent this part. So what is the limit is that when x value is tending to a, how will f of x change? Or I mean to say, there are two things in this particular limit cutting. One, we call it to be RHL, which is right hand limit. The other you could say LHL, which is left hand limit. So what is this right hand limit and left hand limit is that you will be checking how the f of x value is approaching. Like for this we will say x is approaching from a plus. For this we would say x is approaching from a minus. That is, if you see a real number line, or the axis of the real number line, let's say this is the point a. That is, a could be 2 or a could be 3, a could be 2 or a could be 3, or whatever the number, basically the real number. When I talk about x a plus, I am referring to this part which towards the right hand of a. That is, you are approaching to this a, but you are coming from a plus delta. Let's say this is one a plus delta, where obviously delta is positive. You are approaching from a plus delta to a, x axis mein. If I say left hand limit, you are approaching from left hand. That is, let's say this is some a minus delta. A minus delta. What is this a plus delta and a minus delta? Is that a number, a plus delta represents a number which is just greater than a, but there is a very less gap between it. It is not ki this is a and this is a plus 1. This is not we are referring to. This is not what we are referring to. Instead, delta is some number. Delta is some number which lies between 0 and 1. Which lies between 0 and 1. And having said that, this will be actually pretty close to 0. I mean to say something like, if a is 2, then this will be, let's say 2.00001. Let's say this. This will make sense for a plus delta. Similarly, when I talk about a minus delta, I could be referring to 1.99 or 1.998. Still, this is also fine. So point is that we will be checking once we are approaching from here, how the f of x is changing, or here. So what is the situation, or what is the condition being told such that the limit should exist in order to find? In order to say that limit exists for particular function f of x at x equal to a, is that the right hand limit value should be equal to left hand limit value. That is, let's say limit x tends to a, f of x exists. I would say IFF, which is nothing but if and only if limit x tends to a plus f of x is equal to limit x tends to a minus f of x. And let's say this particular value is equal to some L. If that happens, that is, if both the right hand limit and left hand limit will coincide, in that particular case we would say this does exist, and this particular value will also be equal to L. This is what the base definition of limit. We will see with an examples. Any doubts by now? I don't think there are much doubts. That's good to know. All right. So now let us move forward. Let's take this example. Consider the function f of x equal to x square plus x. Find the value of limit x tends to an f of x. See, for this what you could do is, firstly, in order to find this value, as I mentioned, let us calculate firstly right hand limit. That is limit x tends to a plus, that is 1 plus f of x. So what is this f of x? F of x, I can be writing it as x square plus x, which is given in the question. So I would be writing this as x square plus x, let's say. Now x is just 1 plus. So for the sake of calculation, in order to show you the definition, let me use now x is equal to 1.001. Some number which is very much greater than 1. The number which is greater than 1, but the difference is very minute. delta. So if this is the case, what is the f of x value now? F of x value would be 1.001 whole square plus 1.001. What would this value be? 1.001 whole square. It's better I could use make of the calculator, because it's better if we do not spend a lot of time on this manual calculation part. So this entire value would be 2.003. 2.003. Similarly, now let us check for left hand limit. Left hand limit. This would be what? Let's take now x is equal to, which is less than 1. Let's take 0.99. Let's take 0.99. Or for the sake of even better understanding, let's take 0.98. Still that should be fine. If this is the case, let me see what is f of x value in this particular case. I will be getting 0.98 whole square plus 0.98, which is nothing but 0.98 into 1.98. So this should be equal to 0.98 into 1.98, 1.9404. 1.9404. See, the logic is, if you take x equal to 0.098, it is approaching 1.9404. But if you take a number which is still greater than this particular number but less than 1, that is, let's say 0.99 or 0.999, so that value would be even higher than this. That is pretty much close to 2. It will be pretty much close to 2 if you start increasing the x value to the nearest to 1. And if you start decreasing this x value to the nearest to 1, in the case of, let's say, sorry, any issue? No. What is this? All right. So even if you take this value as 1.00001, and if you calculate, that will even be closer to 2. So the point is that as you change the number to this delta, this infinitely small value delta, the approach value is what this limit usually tend to signify. And we were tending to see that both RHL and LHL are being equal to a value which is 2, because this is just 0.98, which is pretty much far to value of 1, because there is a difference of 0.02. This is a huge difference indeed. This is a very huge difference. That is the reason you got 1.94. If you try seeing for 0.999, that would be much closer to 2. So what is the point I'm referring is that as you keep moving from this x value to here and from the right hand, this will keep tending to 2. So in this particular case, I would say indeed this value limit extends to 1 f of x. This particularly asked value, I could simply say, yes, this does exist and this value should be equal to 1 square plus 1, which is nothing but 2. Which is nothing but 2. Hope I'm clear for this example. If any doubts, please let me know, guys. Bhumit Bagdia, no. Acha, okay. Is that for question which I asked, no doubts or what? All right. Or if there is any doubt, definitely please feel free to ask. So here it would be 2. Indeed, I would ask you people to solve this a basic question once. The timer is running. It would be of 2 minutes. Please solve this question. This is pretty much doable indeed. All right, 1 more minute left. I'll just wait because you're able to solve. See, I know it's pretty much solvable in less than a minute indeed for you people, this question. But in order to make you understand what exactly the limit is this question is taken up, uh, you could still think of, even if you finish the question earlier than 2 minutes, obviously, you could think of what's happening at x equal to 0.998 or 0.999, and also think what value is tending at 1.001, 1.0000001. So that is what you have to understand for the basic understanding of precisely what the limit is. The answer is said to be option B. That is fairly true. I would wait for 10 more seconds and then just solve it up. The answer would be B, yes. So, okay, let me solve this now. See, basically here it is asked to find the limit extends to 1 this particular equation. One thing is that when I give this kind of thing, if you see options, there is nothing like does not exist. So this clearly should be a case where LHL should be equal to RHL. You could check that. You could check that precisely. Like if you check it like limit extends to 1 minus f of x, then this would be basically nothing but, let's say, 0.99. Then you will be taking 0.99 whole cube minus 0.99 whole square plus 1, which should be what? 0.999 whole square, 0.999 minus 1. This plus 1 will be there. So basically this value should be tending to 1. The value should be tending to 1. The exact value, see, 0.99 square into 0.0001 minus, so 1 minus very small value are subtracting from 1 ultimately. So this will be approximately tending to 1. Similarly, you could check for limit x tends to 1 plus, still you will be getting the same thing, which should be 1.001, let's say 1.000001 whole cube minus 1.0001 whole square plus 1. This will also be tending to 1. Both will be tending to 1. If you want to see the exact value of this, please do calculate yourself, which you're pretty much capable of doing. So this point, you could say this limit does exist, and that would be equal to 1 cube minus 1 square plus 1, which should be equal to 1. Option B. What's up? Great. So this is the limit example. Now let us see further. Algebra of limits. The topic algebra of limits is nothing but basically when you have a function, how do you deal with it, like f of x plus g of x, or f of x into g of x, or f of x by g of x. So firstly we will see subtraction property. Subtraction property says that limit x tends to a, let's say f of x plus g of x. If this is the thing, this should be equal to individual sum of limits. That is limit x tends to a, f of x plus g of x. Limit x tends to a, g of x. So this is the addition property. What about the, similarly you could see, I could write this plus or minus. No, even the subtraction also holds true. The subtraction also pretty much holds true. That is, if it is limit x tends to a f of x minus g of x, then that should be equal to limit x tends to a f of x minus limit x tends to a g of x. So that is one thing. And you could talk about the other one, which says product. Limit x tends to a f of x into g of x. Two different functions product. This would be precisely equal to limit x tends to a f of x into limit x tends to a g of x. X tends to a g of x, provided both exist, obviously. Having said that, so this is the product rule. You could see the one more, which is indeed important for the sake of questions which you are going to encounter in your exams from the point of view of limits. Limit x tends to a f of x by g of x. This will be equal to limit x tends to a f of x by limit x tends to a g of x, provided g of a is not equal to 0. If g of a is not equal to 0, because if limit x tends to a g of x is being 0, then obviously we won't be able to write this as some number divided by 0, which will go as an undefined quantity then. So this is something which you should be careful of while doing this, because here comes more number of cases in the case of division, where you will see something like 0 by 0 form. That is, if both f of a and g of a are 0, that is nothing but if limit extends to a f of x and limit extends to a g of x is being 0 and 0, then 0 by 0 does not make any sense. We will solve it in a different way known as simplification. I would show how to do that. So let us, I'll write something here. We'll get some two cases here. Let's say we'll get some two cases. One is that, one case I would be able to take up is that, let's say if f of a is not equal to 0. I mean to say the numerator is not equal to 0, comma, g of a is equal to 0. G of a equal to 0. This implies this particular limit x tends to a, f of x by g of x does not exist. This particular limit does not exist, because you're trying to find the limit of this particular thing where numerator is not equal to 0, some quantity, let's say 2 or 2.5 whatever, divided by denominator which is a tending to 0 quantity, then this particular limit does not exist. Whereas the second case is that both f of a is equal to g of a is equal to 0. F of a is 0 and g of a is also 0. If this is happening, this gives me 0 by 0 form. This gives me 0 by 0 form. Here we won't say that limit does not exist. Instead, we try doing the simplification, division simplification. We call that this process as simplification process basically. I will take it up on the next slide. I will take an example for you to understand how to deal with this 0 by 0 form of dealing with limits. Any doubts? Yeah. What if we directly substitute the value of 1 in the question? Okay, that particular question, yes, we did substitute at the end. If you would observe the solution, we did substitute directly the value of 1 at the end, which says 1 cube minus 1 square plus 1, which is nothing but 1 minus 1 plus 1, which is ultimately 1. See, the point is, limits, there is a pretty good chance where sometimes you substitute direct value, you get some value, but there could be a case where actually the right limit and left hand limit may not be getting to the same value. There could be a case where LHL is not being equal to RHL, but still there is some numerical value at point of 1. That is, if f of x is there and f of 1 there is some particular value, but still if LHL and RHL is not being or not approaching the same value, like a discontinuous function, let's say an example of discontinuous function where I would say I wanted to deal with x equal to 0, x equal to 0. Let's say the graph is something like this. Let's say the graph is something like this. I hope you could understand what does this graph, if there isn't a discontinuity at the point you're checking in limit, then directly substituting 1 will also get you the answer. Exactly. One of the student or aspirant, your peer group have mentioned, that is what I'm explaining. So if this is at x equal to 0, this is a discontinuous graph. If I start seeing the values where x left hand limit is going, that is x tends to 0 minus, you will observe actually x equal to 0 is tending to a value, let's say this is minus 2. Example, let's say this is minus 2. Whereas if you check the values where x tends to 0 plus, let's say this is tending to y equal to 2. Now tell me, this graph precisely mentioned or this graph makes you understand that this particular x equal to 0, this is an open point. That is, the at x equal to 0, f of x is 2 actually. It's not minus 2. Here we are opening this. So the graph is discontinuous at x equal to 0. So if you directly substitute when I ask limit x tends to 0 f of x, you would say, sir, I will directly substitute f of 0. That answer would be 2 as per the question which is given. So the answer is 2 for this. But I would say that is not equal to 2. Indeed, I would say does not exist. Here LHL is not being equal to RHL because minus 2 is not equal to 2. Both are not approaching to the same side. That is the reason before you substitute and directly mark the answer, please be careful. There could be an option of does not exist. So you should be clear. See what happening exactly over there. So let us go with this f of 0, the one which we are dealing with, where this particular simplification is to be taken now, 0 by 0 form. I'll take up an example, simplification of division. Let me make a question like this. Limit x tends to 2, I would say, and I would ask for x square minus 4 divided by x minus 2. If I give this particular question to you people, limit x tends to 2, x square minus 4 by x minus 2. You'll be saying, sir, at x equal to 2, this value will be equal to 0. This value will also be equal to 0. So this is precisely what we were discussing about 0 by 0 form. So how to deal with this? How to deal with this? This one have to be simplified in the first place. That is, we should be saying limit x tends to 2. What is this x square minus 4? This is nothing but x plus 2 into x minus 2. A plus b into a minus b is a square minus b square divided by the x minus 2. So what we will be doing is, as we can cancel this both x minus 2 and x minus 2. Why are we cancelling x minus 2? Think, why are we cancelling x minus 2 and numerator on denominator? The reason is that we are interested to find limit x tends to 2. Our question, see, now comes the question of what is the difference between f of 2 versus limit x tends to 2 f of x. Here what makes sense in order to cancel off both x minus 2 in the numerator and denominator, because we are not interested in f of 2. That is anyways will be given in the function itself, right? If 2 is the domain, then what is the equation? We will directly get that. But we are interested at x tending to 2, but not exactly 2. We are tending to 2. We are just tending to 2. So when I'm saying x is some number which is not 2, but either greater than 2 or just less than 2, these values are never 0. X minus 2 and x minus 2 is never 0. So I can cancel off them because those are not 0. Exactly, they're not 0. So I could say I would cancel them. Now I would get limit x tends to 2 x plus 2. So x is something which is greater than 2. So this particular value has to tend to 2 plus 2, which is 4. This is how you have to solve 0 by 0 form. There are some common factors which you can cancel off such that your the given function converts into a proper rational thing where you could get your desired limit value. I hope this is clear. Please let me know if this is clear. That is right answer 4. Shivishri, sir, will we be doing differentiability and application of derivatives as well in this session? Not today. Today, I'll be taking up limits and derivatives. I will focus on continuity, differentiability on the next class. So this is the 0 by 0 form, the way of doing. Let us take few questions. I want you to apply this particular thing and let me know if you are able to solve these questions. The timer starts. Please solve this. I will see how many of you people are able to solve this. One more minute, please keep solving. I will solve for you people once the timer is up. Find the value of limit x tending to 2, x cube minus 4x square plus 4x divided by x square minus 4. This is pretty much solvable by the concepts which we discussed just before. Today, we will also see derivatives, as I mentioned, where we'll also see one more limits concept where it will be interesting. Actually, it will be very interesting to deal with the limits when the trigonometric functions are given, like sine x, cos x, and all those. Because I recently found one of you people were asking on this IIM B UG WhatsApp channel. A question has been posted. I don't know the question source as such, some test question where there is one sine of e power n divided by e power n square plus some n square by n square plus 1 limit and tend to, is it infinity? Yeah, I guess f of 0, I guess there was roughly about. So those kind of questions, basically how to deal when you are given the questions of trigonometric will also be taken care in this today's class. All right, so as the time is up for this particular question, let me solve this for you. Now here it is given that limit x tends to 2, x cube minus 4x square plus 4x divided by x square minus 4. Let's check actually what's happening if we have to apply f of x by g of x. What is f of 2? 2 cube minus 4 into 2 square plus 4 into 2. This is nothing but 16 minus 16, which is 0. F of 2 is being 0. Similarly, let's check for what is g of 2. G of 2 is obviously 0. 2 square minus 4, which is again 0. So basically, this is the form which we were discussed just before, that is 0 by 0 form. 0 by 0 form. So in order to deal with this, as I mentioned, we have to simplify the given equation. We have to simplify the given equation. So let us do that. Given is x cube minus 4x square plus 4x. 4x square plus 4x divided by x square minus 4. So this can be written as what? I will take x common in the numerator, then I will be getting x into x square minus 4x plus 4 divided by the same x square minus 4. Now, what is x square minus 4x plus 4? This is nothing but x minus 2 whole square. Because what is x minus 2 whole square? X square plus 4 minus 4x. That is what this particular term is. So this can be written as x minus 2 whole square into x divided by x square minus 4. What is x square minus 4? X plus 2 into x minus 2. A square minus b square is a plus b into a minus b. This is the thing. Now this can be, again, as x is just tending to 2, not equal to 2. I would cancel x minus 2 once. Then I would get x into x minus 2 divided by x plus 2. Now I would say limit. Now I would apply this particular thing of limit x tends to a f of x by limit x tends to a g of x. Because this is no more a 0 by 0. This is no more denominator being 0. So this one I'll apply. I would get x equal to 2 into 2 minus 2 in the numerator divided by 2 plus 2. So basically I'm getting 0 because 2 minus 2 is 0 whereas denominator is 4. So this particular value will at x equal to 2 give me 0. So the answer should be 0 for this particular question, that is option A. Option A. Any doubts? People were able to solve this. Great. Good to see. So this is the value of limit for this particular question. Let us move forward. Solve this particular question. One sec. Yes. Solve this particular question. Once you get the logic behind solving 0 by 0 forms, it is pretty easy question indeed. People were saying the answer is what? -4? Okay, let me see. All right. That should be right. Please, if you find any difficulty in understanding, don't hesitate at any cost. Please do post your questions on the chat box. Okay. So I'll take up this. Find limit x tends to 2 x cube minus 2x square by x square minus 5x plus 6. As you could see, at x equal to 2, 2 cube 8 minus 2 into 4, which is again 8, divided by x equal to 2, this will also be 0. So basically this will be 0 by 0 form given. Let us simplify the given thing then. X cube minus 2x square. This can be written as x square into x minus 2. What is x cube minus 2x square? If I take x square common, it is x square into x minus 2 divided by, given is x square minus 5x plus 6. X square minus 5x plus 6. This is nothing but x minus 2 into x minus 3. It's a quadratic equation with the roots 2 and 3, which is nothing but x square minus 5x plus 6. That is what here it is given, x square minus 5x plus 6. The numerator is x cube minus 2x square, which is nothing but x square into x minus 2. Now limit x tends to 2. So I could cancel this off again. So I would be getting ultimately the simplified form is x square by x minus 3. X square by x minus 3. Now the point is limit is x tending to 2. So the same thing I will apply, limit x tending to 2. Now it is no more 0 by 0. Extending to 2 x square divided by limit extending to 2 x minus 3, which is nothing but 2 square by 2 minus 3, which is minus 1, which is nothing but minus 4. The answer should be minus 4 for this particular question. That is option A. Sir, will we have a class on complex numbers as well, as it's part of the 11th syllabus? If it is yes, it is the part of 11th or 12th syllabus for sure, complex numbers. So we will be taking it up, where in the case of complex numbers, precisely we should be dealing with one thing. The area where I can expect a question is that expressing in polar coordinates, where you will be expressing it as r sine theta or cos theta and then solving the question, and some iota multiplication. Nothing more than that is what I expect. So we could definitely take that up for sure. Let us move forward now. Let us see this particular theorem, which says for any positive integer n, limit x tends to a, x power n minus a power n divided by x minus a. If you see here, this is nothing but what? This is again 0 by 0 form, right? Because limit x tends to a, x power n minus a power n would be a power n minus a power n, which is 0, divided by x minus a is again 0. So 0 by 0 form precisely. So this particular value is being said to be equal to n into a power n minus 1. How is this n into a power n minus 1? Let us see. So again 0 by 0. So we have to simplify. So if I have to simplify, I would say limit x tends to a, x power n minus a power n. What is x power n minus a power n? Can I write it as x minus a into, let's say, x power n minus 1, because ultimately I need x power n, no? So x power n minus 1 plus a into x power n minus 2 plus a square into x power n minus 3 and so on, like a cube into x power n minus 4 and so on, till what I expect this to be going is a power n minus 1, because ultimately we should be getting minus a power n. Only two terms in the numerator is what we are interested to resulting should be. So I would be taking this as plus a power n minus 1 into x power 0. So basically, if you could see this, why did I write in this way? In order to cancel 0 by 0 simplification form, divided by x minus a is anyways given in the question. So in this particular case, what's happening is that if you could focus on this particular x power n minus 1 plus a x power n minus 2 plus a square into x power n minus 3 and so on, you could observe one thing, that if I do x power n minus 1 into x, I'll get x power n and minus a into x power n minus 1, which is again nothing but plus a into x power n minus 1 when I multiply these both terms. Similarly, again a square x into n power minus 2, but with a, if I do this, again I'll be getting minus a power 4 into x power n minus 4, or here you already got minus a into x power n minus 2, you do minus a square into x power n minus 2. So minus a into this is minus a square x power n minus 2, x into this is a square into x power n minus 2. So every time, the logic behind this is you will get one negative term and one positive term, negative term and one positive term. So those keeps getting cancelled, resultant effectively. You will be only left out with x into x power n minus 1, which is x power n, minus a into the last term, which is a into n power minus 1, which is a power n. So this particular x power n minus a power n, I can be writing it as this equation. Am I clear till here? So what if we could not simplify? We should be able to simplify. If we do not simplify, the limit does not exist indeed, because you could never see a 0 by 0 form unable to being simplified, because see, if it is 0 by 0 form, the value has to tend to a particular thing. If I would see, why is it in this way? See, if the value is tending to 0 by 0, let's say some value is 0.002 divided by, let's say one more value is 0.000001. These both are tending to 0 only ultimately. But still, is this value something like undefined or infinity or something like that? No, right? Because this particular value is a pretty much numerically solvable. And one more thing which you have to understand is, there is only two cases which can happen. One is either this function which is given, which is f of x by g of x. This functions, there is no, if you take this particular function as h of x, let's say, so this particular function has some new h of x. If that h of x is discontinuous at that particular point x equal to a, or the point which we are talking about, x tending to a, right? So x equal to a, if this entire function is discontinuous, then limit does not exist, because LHL will not be equal to RHL. But other than that, that is, if LHL is being equal to RHL, when you simplify it using the numerical value, usually we don't do that, but if you want to verify additionally, you could do that by taking a plus value and a minus value, and you could see if these both are approaching to a common value, then limit definitely exists for this function. That we should be able to simplify. And I don't think I've ever seen any question being framed on where you are unable to simplify but still being asked in a 0 by 0 form. That won't happen for sure. So having said this h of x thing, please, this was taken not for this part of question, but for the question which is asked on the chat box indeed. So now let us see this particular theorem. Am I clear for that particular question? The one which I asked was, what if we could, yes, who is this? Bhumit Bagdia. Was it clear? The one which I mentioned 0 by 0. Please let me know if you have further doubts, we can discuss on it. So if x is tending to a, and if I were able to cancel these both, then what will be coming? A power n minus 1 plus a into a power n minus 2 plus a square into a power n minus 3 and so on till a power n minus 1. So ultimately, if you see here, what am I getting? I'm getting a power n minus 1 plus a power n minus 1, again a power n minus 1 only, so on a power n minus 1. How many times a power n minus 1 is coming? Starting from x power n minus 1, I am going till x power 0, because what is a power n minus 1 into 1 is x power 0, right? So n minus 1 to 0, that is nothing but I'm having total n number of terms. So I would be getting n into a power n minus 1. This is what the particular theorem says. Limit extends to a x power n minus a power n divided by x minus a is n into a power n minus 1. So now, if people are already aware of differentiation part, which I did not discuss, but if you are already aware, you could simply say, sir, differentiate this particular thing, then I would get n into x power n minus 1. I would differentiate denominator, I'll get 1. So that is n into x power n minus 1. That is also fairly true. But why is it differentiable and how to find that, that will be taken in the further sessions as we keep proceeding in the calculus part. Okay. So please make note of this. This comes very handy indeed. Let us see forward. I think I can take up a question on this particular thing. Just solve this up. I think by now people should have been solved this question. If you are a bit understanding how to manipulate the things directly, how to manipulate this kind of things, or the one which we just discussed, as such, there is nothing new in it. You could just think of it for a minute or so. So then you will easily end up getting the right answer. Ten more seconds. I'll be solving this. All right. So let me solve this question. Limit extends to an x power 15 minus 1 by x power 12 minus 1. So this is again a 0 by 0 form. Need not mention. It's very much visible to you people. So how do I write this? How do I rewrite this? Limit extends to 1, x power 15 minus 1 divided by x power 12 minus 1. X power 12 minus 1. This is what it is given. This is what. So see how I could write this in this way. Na? Limit extends to 1, x power 15 minus 1. 1 can be written as 1 power 15. There should be no issue. Divided by x minus 1 whole by again x power 12 minus 1 power 12 divided by x minus 1. This doesn't change my function as such. This doesn't change my function's domain, neither the function. So writing this given thing in this format will help me to say that these both are non-zero. When I take limits for each individual function of numerator and denominator, I know those are non-zero because each one is 0 by 0 form. They have their particular limit values which are non-zeros. So I could say this is basically this limit divided by this limit. But what is this again? Nothing but. This is nothing but basically x power n minus a power n by x minus a divided by x power n minus a power n by x minus a. So what is this value? This is, as we just discussed as a theorem before, x power n minus a power n by x minus a will be n into x power n into a power n minus 1. So this should be 15 into x power 15 minus 1, which is 14, divided by this should be 12 into x power 11. But we are interested at limit extending to 1 na, limit extending to 1 na. So this particular value should be equal to what? 15 by 12. 15 by 12, or simplified value would be 5 by 4. So this should be 15 by 12. Should be 3 5s are and 3 4s are. Answer should be option D. I hope I'm clear. We should continue classes from website or YouTube. Could do it from the YouTube, I would say indeed. Or the website also, because Cracku.live, you could answer these questions if I'm not wrong. I think tech team, or I mean to say the support team, should be able to clarify this. Please, if anyone listens to or see at that particular comment, please do give an appropriate reply, or else we would be letting you know before the tomorrow's session for sure. So this is 15 by 12. Hope I'm clear. Let me solve. Let me pose one more question. Solve this. Hope the timer is the same, right? Yeah. This is also 0 by 0. So think how to write this. Okay, Yogasri saying the answer should be option C. So someone is saying answer is option B. Okay. Anyways, I'll be solving it after 10 seconds. Let's see if it's option C or option B. Whatever. All right. I think the time is up for this particular question. Let us solve this. So this is a 0 by 0 form again. So I would just write this as limit x tends to 0, x plus 1 power 5 minus 1 divided by. So how can I write just the numerator, or just the denominator which is given as x? This can simply be written as x plus 1 minus 1, can be written as x plus 1 minus 1. Now, what is the advantage if I write it in this way is that I would now take, let x plus 1 is equal to some t. Let x plus 1 is equal to some t. If x plus 1 is t, I could rewrite the limit to be limit. See, if x is tending to 0, this implies t is tending to 1. T is tending to 1 because x tends to 0 and let x plus 1 is some variable t. Then if x is tending to 0, the variable t should be tending to 1, because 0 plus 1 is 1. So t should be tending to 1. Instead of writing limit x tends to 0, I would write limit t tends to 1, and x plus 1 is t. So this is nothing but again t power 5 minus 1 by t minus 1. Again, this is nothing but limit x power n minus a power n divided by x minus a form. So what is this should be? N into x power n minus 1. So a t tending to 1, this would be 5 into 1 power 4, which is 5, which is 5. So the answer has to be option B, 5. The answer has to be option B, 5. B5. Right. So basically, this is just a thing where you could easily figure it out, where you could take x plus 1 as some variable. That sometimes you get a very good question where it takes time in order to think how to manipulate it or how to get the variable such that I was able to solve it. And one of your friends have asked just some time before, what if we could not simplify 0 by 0? Actually, you could simplify, but there is a very good chance if a question is framed in a way where it's not very easily striking on how to choose the variable, how to manipulate it so that you will end up being able to answer that particular question. That comes with a lot of practice. So this is the way for this particular question. Now, okay, I also took one more question. All right. Okay, solve this. No worries. Because we should be covering today much more things. We should be taking up trigonometric thing and we should be going to derivatives a bit. It will be till 5, I guess, today. It will be extended a bit, timer. Hmm. Right. So this particular question, there is no big difference other than just powers being in the form of p by q form. It's not a direct integer, but more or less the same thing. So you should be writing this limit x tends to 1 x power 1 by 3 minus 1 divided by x minus 1 divided by limit x tends to 1. Same thing again, x power 1 by 5 minus 1 divided by x minus 1. This is again x power n minus 1 by x power n minus a power n by x minus a. So this is nothing but again 1 by 3 into x power minus 2 by 3 because 1 by 3 minus 1 divided by 1 by 5 into x power minus 4 by 5. But we are interested at x tending to 1. So this should be what? 1 by 3 by 1 by 5. This should be 5 by 3. So the answer has to be option C, 5 by 3. Yes, right. Okay, this is fairly simple. I hope we got a good hang of it. Now let us see what is a sandwich theorem. So basically this comes very handy during limits dealing with trigonometry. Limits dealing with trigonometry. So here we will be using usually what is a see this theorem, or this is also known as the other name of this theorem to the best of my memory, squeeze theorem. But please do, and you can check it on online once if it's squeeze theorem or whatever. The name doesn't matter ultimately, but you could call it as per your wish, I would say. So if there are three functions, let's say there are three functions like f of x, g of x, h of x, and if f of x is less than or equal to g of x, less than or equal to h of x in their particular domain. If f of x is less than or equal to g of x, less than or equal to h of x in their common domain, in their, because see, f of x, g of x, h of x, all three need not have a same domain, but there will be some common domain which caters to all three. If this is true in their common domain, if this is true in their common domain, then now I talk about A, then a point A, x tending to A, which is in domain, obviously A should be in the domain. So if this is the thing I'm talking about, if, please make this word, if limit x tending to A, f of x, if that gets equal to limit x tending to A, h of x, okay, limit x tending to A, h of x as some value L, if this is happening, that is f of x less than or equal to g of x less than or equal to h of x for their common domain, and limit x tends to A, f of x being equal to limit x tends to A, h of x, let's say that limit is L, then therefore we could definitely say limit x tending to A, g of x would be equal to L. Limit x tending to A, g of x equal to L. So where do we use this? There are terms where we are unable to decide exactly where sin x, let's say for example sin x, because the reason why I'm interested on sin x is that is fairly primary example which we can take to explain this, where I would say, let's say sin x, we all know sin x is a bounded function which lies between -1 to 1. Sin x is a bounded function. You take anything which is in the domain of sin x, it would be in between -1 and 1. So if this is f of x, g of x, h of x, now I would ask, if I would ask, find sin x by x, limit x is tending to 0. If I ask you that particular question, or this, why am I interested in this is that sometimes sin x divided by x, limit x tending to 0. Here comes the case where you would see this will be sin 0 is 0 divided by 0. This is ultimately being 0 by 0 form. Now you should be asking, sir, how to simplify this particular thing sin x by x? How to do it? So here there is no algebraic way where you can do that directly. See, because if you wanted to do it algebraically also, there is one way, that is known as Taylor series. You should be able to expand this sin x in Taylor's format. That would be, even I totally forgot the sin x expansion of Taylor series. But having said that, that won't be a part of your examination for sure. So if you go for sin x Taylor's expansion and divide that particular expansion by x, then substitute x tending to 0, you'll get the answer for sure. But even before doing that, let me show you how to deal with this particular limit x tends to 0 sin x by x. We will use sandwich theorem over there, which says h of x, g of x, h of x. If you see, basically this theorem says graphically something like this. Let's say, what is this? F of x, g of x, h of x, right? So h of x is at the highest. Let's say one more point, g of x. Let's say the other point is h of x. What it says is, okay, f of x, g of x, h of x. So this is h of x. This is the bottommost is f of x, and this is g of x. F of x is less than or equal to g of x, less than or equal to h of x. If this g of x, if this h of x and f of x limit at x being at x equal to a is tending to a particular value, common value, let's say this common value is L, then this g of x, where in its entire domain, I told the definition is very clear, it is in its entire domain, common domain. Every time if g of x is greater than f of x and f of x is also tending to a, then definitely g of x should tend to a, because h of x is also a, which is always greater than or equal to g of x as in their common domain. Is this thing the one which we are referring to, that is being proven here graphically? Are you being able to understand why is this happening? Exactly why this inequality holds. I mean, if this inequality holds, why this limit being common? Are you being able to understand that particular point? Please do respond here. Are you being able to understand in this common domain, if this every time happens, that is h of x is greater than or equal to g of x is greater than or equal to f of x, then if h of x, f of x limit is coinciding to a value called L, then definitely g of x should also coincide to the value L at that particular x equal to a. Is this understandable, guys, from the graphical point of view? We'll just wait for your response so that I'll move forward and take up one interesting topic. I mean, on the same thing, on the sandwich theorem, where usually I'll pose you a question on functions. You have to think a bit how it turns out to be. Is that clear, guys? Okay, I'm unable to see any comments as such now. I think there's a delay in how these things are working. Okay, so this graphical thing says why if this particular inequality holds in their common domain and if this limits is getting coincided at a common point of L, then g of x should be equal to L. Yes, sir. Yes. Okay, great. So if once you understood this proof of this theorem, it will be easy for me to prove this particular thing. Please make note of this, guys. Sin x is less than x less than tan x. For any x, let's say for any x, x radians, which is from 0 to pi by 2, let's say common domain, because sin x is minus pi by 2 pi by 2 and tan x is also minus pi by 2 pi by 2. I will be taking some x positive value. I'll be dealing with positive value to say precisely. So 0 less than x less than pi by 2. If you take this domain, this sin x less than tan x always holds true. This I'll prove this. Why is this sin x is less than x less than tan x? But what is the application part of it? Why do I prove this and what is the essence of this is, if I ask you a question, first question, if I say number of solutions of sin x is equal to x. Sin x is equal to x. Number of solutions of sin x equal to x. You would be saying that number of solutions of sin x equal to x is, sir, at the rate x is equal to 0. At the rate x equal to 0, that is at the value of x equal to 0, these both will be 0 and 0. So 0 equal to 0. One is x equal to 0 is the solution. But how do you say there is no other x value? See, for this particular question, the answer is only 1. That is x equal to 0. But why? How are we being sure that sin x will be equal to x only at x equal to 0? Graphically, you could say, sir, sin x graph and x graph, y equal to x graph will be in this way. This is y equal to x. This is y is equal to sin x. Here, there is definitely an intersection 0, 0 point. But how are you sure that y equal to x is always greater than sin x for any value other than 0? This is what we are interested in now. Because once we are able to prove this, we should be able to find the value of sin x by x limit extending to 0 by using our sandwich theorem. I will tell you how to do this also. Are you understanding what is this sin x equal to x and everything? If it feels a bit difficult or anything, please let me know. You can definitely let me know in the chat box so that I would take up some more time in explaining this particular thing what I am referring to. Now we will be seeing why this sin x is less than x less than tan x. How to do that? See, let us take one circle of degrees x radians. Let's say this is the center. Let's say this is the point. Say this is center O. Let's say this is point A. Now I'll take a perpendicular. There is a tangent to this circle at point A. I'll take a tangent to the circle at point A and I will join these points. Let's say this is B. Let's say this is particular point B. This is a tangent. I'm saying that this is a tangent. Okay, this is B. Now this intersection point of the line B, C, and I'll drop one perpendicular here. I'll drop one perpendicular here onto OA. I'll drop a perpendicular to OA. Now, let this angle be X. Let this angle be X. Here X is obviously, I'm saying, less than pi by 2. That is less than 90 degrees is what I'm mentioning. 0 less than X less than pi by 2. Now what's happening is that, if you could see here, focus on, let's join C and A. Let's join C and A. Focus on triangle OCA and sector area OCA. See, I mean to say this particular triangle OCA. See, triangle OCA. Okay, wait. Triangle OCA area, you should focus. This will definitely be less than sector area OCA, sector of OCA. See here, this is OCA triangle, the line which we have joined in this way. This will be OCA triangle, whereas the sector have this additional area, the shaded area, the additional shaded area including OCA, because the sector is what? This entire area. But when I talk about only triangle OCA, that would be triangle OCA area less than this sector area, because the additional area is the shaded one for the sector. That will be the case. And this sector, this entire OCA is even lesser than triangle OAB, lesser than triangle OAB, lesser than triangle OAB, which is a bigger triangle which includes OCA, and even above the area which lies outside circle. This part, this triangle OCA area is less than sector OCA area, less than triangle OAB area. Any doubts, please keep posting, because this is an important proof. Should have clarity on this proof. When I take this up, when I say this is the inequality, how to write this? This can be written as, what is OCA area? Area of triangle OCA, that is half into base into height. Base is nothing but OA. Height is nothing but the perpendicular which I have drawn from C to OA, that is CD. So this can be written as half into OA into CD. Half into OA into CD. Half into OA is the base, CD is the height. That will be the area of triangle OCD, which should be less than sector area OCA. Sector area OCA. What is the sector area with x degree? What is the sector area OCA with x degree? That should be x by 2 pi, because the entire circle is what? For 2 pi radians, 360 degrees. So for x degrees, it should be x by 2 pi into pi r square. Pi into r square. Because for 2 pi radians, the area of the circle is pi r square. For x radians, the area of this particular sector OCA would be x by 2 pi into pi r square. Now similarly, let's check for OAB. OAB. This is a right angle triangle. This is a right angle triangle. How could we write this? For the right angle triangle, I could be taking up one thing which says half into BA into OA. What is this? Half into BA into OA. Because this is half into base into height in a right angle triangle, BA and OA. Till now, is this clear? Is this clear, guys, till now? Yes, okay. Now, what am I doing here? See. Now, what is this? Pi can be cancelled, x by 2 pi into this, and 2 in everywhere, 2 in every denominator can be cancelled off. I'll be getting OA into CD, OA into CD less than x into r square. What is r square? What is r square? R is nothing but OA, R is nothing but OA, or OC, both are R, both are radius R. So this can be written as x into r square is nothing but OA square, should be less than, what is BA? BA into OA. What is BA? This is BA. In this right angle triangle, OAB, this is 90, this is x degree. Okay, this is OA, this is BA. So what is tan x? What is tan x? Opposite by adjacent. That is nothing but BA by OA. BA by OA. What is tan x? BA by OA, opposite by adjacent. So what is BA can be written? BA can be written as OA into tan x. OA into tan x is what? BA. OA into tan x is BA. So I could write this as BA is OA into tan x. So OA square into tan x. Because BA is OA into tan x into OA, which is again OA square into tan x. OA into CD. So what is this CD again? Let's check what is CD. This is particular thing CD. That is again a right angle triangle. Now this is CD, this is O, this is D, this is C. This is a right angle triangle with x degree. OCD na. See, this is not radius. OD is not the radius, but OC is the radius, because OC equal to OA. OC is equal to OA, which is equal to radius of the circle only. OC equal to OA. So here, sin x, if I see, sin x, would be nothing but CD by, that is opposite by hypotenuse. Hypotenuse is OC. Hypotenuse is OC, which is again radius, that can be written as OA because OC is equal to OA, because OC equal to OA. So CD is OA into sin x. So CD can be written as OA into sin x. Now, why did I write this? So that OA square can be cancelled across all the three. OA square can be cancelled across all the three. Now this is gone OA square, this is gone OA square, OA into OA is OA square. So hence we can prove that sin x is less than x less than tan x. Sin x less than x less than tan x. So this is how you can prove geometrically, where by ensuring triangle OCA area is less than the sector area, which is again lesser than the bigger triangle OAB. By doing this particular thing, you will geometrically say sin x is less than x less than tan x. Sin x is less than x less than tan x. This is what we have mentioned here. Is this proof clear? This is the main part of trigonometric limits. Please do respond, guys, if this proof is clear or not. I hope this proof should be very much clear because we spent a lot of time only on this one thing, sin x less than tan x. Now, if this is proven, sin x is less than x less than tan x, then y equal to sin x or sin x equal to x. For the number of solutions of sin x equal to x, we know sin x is less than x less than tan x. So that is nothing but what? X is always greater than sin x in its common domain. X is always greater than sin x in its common domain. So this is sufficient. This is sufficient, other than it x equal to 0, obviously. Any value of x, which is, we are talking about x greater than 0. We are talking about x greater than 0 because if x is equal to 0, OB makes no sense, CD makes no sense for us. At x, other than at x equal to 0, any other value, we are sure x is greater than sin x by doing this particular geometrical area. So if sin x is greater than x, if the question is sin x equal to x, I would say other than at x equal to 0, every time x is greater than sin x. So only solution would be x equal to 0 and sin x equal to 0. So am I clear? Okay, fine. So when I say x equal to sin x greater than sin x or tan x, now let us see our limit ka thing, the limit which we are interested on to exactly. How to do limit x tending to 0 sin x by x. How to do the limit x tending to 0 sin x by x. So the same sandwich theorem let us apply. Here f of x is equal to sin x, g of x is equal to, let's say, see, instead of f of x, g of x taking it now, I will rewrite that inequality because that makes our work easier. I would rewrite this as sin x less than tan x is there, no? I will divide everything. Tan x can be written as nothing but sin x by cos x. So I will divide this entire by sin x because in x0 to pi by 2, that is x greater than 0, sin x is positive, x 0 to pi by 2, the common domain which we are dealing, sin x is positive. So I can divide entirely with sin x on all the three terms. I would get sin x by x, sin x, that is 1, x by sin x. Again, this is 1 by cos x. This is 1 by cos x. 1 by cos x. Because I need not change the inequality sign because sin x is positive in this particular domain. So how can this can be written as? This can be written as just reciprocal of everything, that is sin x by x less than 1 less than cos x. I'll just do the reverse thing. That is, I would be just doing the reciprocal of each term. I would get 1 by 1, I would get sin x by 8, I would get cos x. But inequality changes when you do the reciprocal. That is, if a is greater than b, then obviously 1 by a is less than 1 by b. When you do the reciprocals, the inequality sign changes. So when I do reciprocal, I would get 1 greater than sin x by x greater than cos x. that is nothing but cos x less than sin x by x less than 1. Okay, I'm just seeing if you have any doubts. So if this is the case, if this is the particular case, now we are interested on limit extending to 0 sin x by x. Now, how can we deal this? Using sandwich theorem, now I would say f of x is cos x and h of x is 1. H of x is 1. Now I would say limit extending to 0 f of x is nothing but cos 0, which is equal to 1. F of x is cos x, so limit extending to 0 f of x is 1. Similarly, limit extending to 0 h of x is also equal to 1. So if this f of x, this both values are tending to 1 at x equal to 0 or limit extending to 0, then the part which is in between these both, the function, should also be tending to 1 as per the sandwich theorem, because sandwich theorem we already proved the three graphs functions where this particular h of x is always greater than g of x, which is also always greater than f of x. Then if this f of x and h of x, the least and the highest functions, are tending to a common value, then definitely g of x should also tend to that common value limit, that is 1. This is how you will say limit extends to 0 sin x by x is 1. This is really important, guys. Limit extends to 0 sin x by x is 1. This particular value is equal to 1. Based on this only we will take up now questions. I hope I'm clear. Based on this, I will be taking up some questions now. Let us move forward. Please try to solve this, guys. Okay, where is the question? Okay. Okay. This is the question. Please do solve this. After taking one or two questions, we can move to derivatives. Use all the things which we have discussed till now, that is all the theorems or all the way of solving the limits. We have discussed algebra of limits. I'm giving the hint to make every one of you solve this question. Use theorem of algebra of limits. Use the thing which we just discussed, that is limit extending to 0 sin x by x is 1. Then try to answer this. This will be pretty much easy question actually, but if you tend to apply it well, then it's very easy. Else, it could be difficult. If anyone were able to solve this question, please do post the answer. I would be happy to see if someone solves this. Okay, someone is saying option B. Why is it option B? Why is it option B? That's wrong. Please do think. Change the option. You said option C. Then I guess it could be right. You change the answer. That's fine. So I'll just solve it. I'll just confirm you once I solve this. So limit x tends to 0, 1 minus cos x by x, which is nothing but 0 by 0 form, because 1 minus cos x is 0 at x equal to 0 and x is 0 at x equal to 0. So 0 by 0, how to solve this is that, see, you know this cos, okay, let me write it big. Cos x is nothing but 1 minus 2 sine square x by 2. 1 minus 2 sine square x by 2, or nothing but, you could also say cos 2x or cos 2 theta, let's say cos 2 theta is 1 minus 2 sine square theta. I'm sure you people might have known this trigonometric thing, which is pretty much used in your 11th and 12th grades. Cos 2 theta is 1 minus 2 sine square theta. So cos x is nothing but 1 minus 2 sine square x by 2. So I will write numerator 1 minus cos x as limit extending to 0. 1 minus of cos x I will be writing as 1 minus 2 sine square x by 2, divided by the same x I will be writing as x. What is this thing is equal to is that limit extending to 0, 1 minus 1 will go away, minus into minus plus, I will get 2 sine square x by 2. This is nothing but what? Sine square x by 2 is sine x by 2 into sine x by 2. See, 1 minus 1 will go away, minus into minus plus, plus 2 sine square x by 2. 2 sine square x by 2 is nothing but 2 sine x by 2 into sine x by 2, divided by x is as usual. Now what will I do is that I will write this as what? See, this x can be written as x by 2 into 2. X by 2 into 2. Any issues? When I write denominator x as x by 2 into 2, that should be the same. So having written in this format, I could cancel 2 on numerator and denominator. Then I would get limit extends to 0 sin x by 2 by x by 2 into sin x by 2. That is, now I'll apply algebra of limits, which says limit extending to 0 f of x into g of x is nothing but limit extending to 0 f of x into limit extending to 0 g of x. Limit extending to 0 g of x. So limit extending to 0 f of x into g of x is limit extending to 0 f of x into g of x. I will apply that for this particular manipulated format. I would get limit extending to 0 sin x by 2 by x by 2 as one function f of x into, I would take limit extending to 0 what, sin x by 2 as the other function. Now I know that limit extending to 0 sin x by 2 divided by x by 2, this is nothing but limit extending to 0 sin x by x, because when x is tending to 0, I could say obviously x by 2 is also tending to 0 only, no? X by 2 is also tending to 0 when x is tending to 0. So that is nothing but limit x by 2 tending to 0 sin x by 2 by x by 2, because x by 2 can be taken as t, you will get limit t tends to 0 sin t by t, which is nothing but 1. So this is 1 into, what about this function? Limit extending to 0 sin x by 2, that is limit x by 2 tending to 0 sin x by 2. This is 0. 1 into 0. So the answer has to be 0 for this particular question. The answer has to be 0 for this particular question. That is option A. Few people, 1 or 2 people have said answer to be 1. You might have done a mistake. Probably, please check yourself, because this one probably you might have got right till this point, 2 sin square x by 2 by x by 2, and you have tempted to see x by 2 by x by 2, sin x by 2 by x by 2, so answer is 1. But please do not forget there is sin x by 2 additional, that is sin square x by 2, not just sin x by 2. So probably I feel the people who got 1 should have approached till here thinking it to be 1. Into 0 is what they might have overlooked, is what I feel. Having said that, the real issue in where you have got 1 is exactly known only to you. You can recheck where you went wrong. If there is any issue in understanding this particular solution, you can ask me, because you should be able to understand this is 1 into 0 ultimately. So this should be 0. Any difficulty in understanding this question? Please let me know. Meanwhile, try to solve this. This is even fairly simple question comparatively than what we solved just before. Just one thing, guys. In this question, it should have been mentioned A is not equal to 0 and B is not equal to 0. I think it is assumed. You can definitely take this. Anyways, if you take A equal to 0 or B equal to 0, then my question doesn't make sense at that point of time. But I should have mentioned in the question A is not equal to 0 and B is not equal to 0. That makes more sense. For 30 seconds more, after that I'll be solving this. As I mentioned today, the class will be taken till 5 because you people already know calculus is itself very huge topics, requires a lot of time in explaining concepts, and calculus is such a part where explaining concepts doesn't make much impact unless you provide that application part. Because if you see, whereas arithmetic or algebra, even algebra not, let's say arithmetic or some topic like even the geometry needs application morely, but this is the topic where I feel limits, differentiation, derivatives will make sense only we take the examples and questions, because it's not fairly simple to do only with the concept in this particular topic. Okay, so having said that, the previous question, as I mentioned, any doubts, please definitely post it on the comments. I'll be looking about it. But this question, find the value of limit extends to 0 sine ax by sine bx. That is nothing but 0 by 0 form. 0 by 0 form. How to rewrite this? This can be rewritten as limit extends to 0 sine ax. I will write this as by ax into ax. By ax into ax, because sine ax can be written as sine ax by ax into ax divided by limit one sec, not this entire divided, okay, divided by, similarly I will write sine bx as sine bx by bx into bx. That should not be any issue in the writing this way, because both are same. Sine ax by sine bx is nothing but this one, the way we have written. Why did I write it in this way is that, if you could see, now in this particular thing, I can cancel xx because x is tending to 0 but not exactly equal to 0. So x's can be cancelled on the numerator and denominator. Then I would get numerator a and b, which I can write in this way, a by b outside, because it's a constants, right? A and b are not the functions of x. A and b are constants. And as I mentioned, those are not equal to 0. A and b are not equal to 0. Some constants, non-zero constants. So a by b can be brought outside the limit, and I could say limit x tends to 0, this particular thing. This particular thing, again, now I'll apply what? Limit extending to 0 f of x by g of x is nothing but limit extending to 0 f of x divided by limit extending to 0 g of x. Limit extending to 0 g of x. That is limit extending to 0 sine ax by sine bx by bx. But what is this equal to? Limit extending to 0 sine ax by ax is nothing but limit ax tending to 0 also, because x is tending to 0. A is a non-zero constant, ax is also tending to 0. This value is 1. This value will also be 1, because bx will also tend to 0 similarly. So this would be a by b into 1 by 1. That is nothing but a by b. That is nothing but a by b. So this answer should be option. Where is my option? Okay, here I have written this off. Sorry. So it has to be option B. Here, A comma B are not equal to 0. This is in the question only. This is in the question only. So is this clear, guys? Please do respond to me. If this is clear, we'll keep moving forward. This is simply we just manipulated sin AX by sin BX as sin AX by AX into AX divided by sin BX by BX into BX. XX goes away. A by B is a constant which comes out. Then I could write this f of x by g of x as limit f of x by limit g of x, because both are now non-zero, and now that should be x by x, which is 1. That limit x extending to 0, sin ax by x is 1. Similarly, sin bx by bx will also be 1. So a by b into 1. Clear, guys? Yes, sir. Cool. So now let us move forward. Okay, one question. Try this. Keep doing this for a 2-minute time. Once the timer ends, I would discuss this question. I will be back just for a minute. All right. The time is up for this particular question. Let me solve this for you. Limit extends to 0, ax plus x cos x by b sin x. What is this x equal to 0? A into 0 is 0 plus 0 into cos 0 is 1. So a into, this is basically 0 by 0 format. Nah? B into sin 0 is 0. So we have to simplify it. When it is 0 by 0, we have to figure out a way to solve this. That is nothing but limit extends to 0. Now I'll apply algebra, which said that algebraic law of limits, which says limit f of x plus g of x limit is nothing but f of x limit plus g of x limit, right? F of x limit plus g of x limit. G of x limit. So this one is what we will be doing now. Limit extends to 0, ax plus x cos x by b sin x. So how to do this? This can be written as limit extending to 0, ax by b sin x plus limit extending to 0, ax by b sin x plus limit extending to 0. What is the other one? The other one is x cos x by b sin x. X cos x by b sin x. So having written in this way, this is nothing but what, guys? This can be written as limit extends to 0, a by b is there, into this is 1 by sin x by x, sin x by x. X in the numerator is just brought to the denominator. Similarly, here also I could write limit extending to 0, cos x by b into 1 by sin x by x. Sin x by x. Why am I doing this way? Because limit extending to 0, sin x by x is 1. Limit extending to 0, sin x by x is 1. So in this particular first term, a by b is a constant which comes out 1 by sin x by x, 1 by limit extends to sin x by x is 1. So this is into 1 plus similarly limit extends to 0 cos x by b. Cos x by b is nothing but cos 0 is 1. So 1 by b. This is cos 0 is 1. So 1 by b into again limit extends to 0 1 by sin x by x, which is nothing but 1 by 1. Why is it so? This particular thing we have just written it as limit extends to 0 f of x into g of x is nothing but limit extends to 0 f of x into limit extends to 0 g of x. So limit extends to 0 cos x by b into limit extends to 0 1 by sin x by x. Limit extends to 0 cos x by b is nothing but cos 0 is 1 and denominator is b, which is 1 by b into 1 by 1. So we are getting basically a by b plus 1 by b, which is nothing but a plus 1 by b. A plus 1 by b. We should be getting this answer. Let us see the option a plus 1 by b. That is option D. That is option D. Option D. So students of applied maths are expected to learn trigonometric calculus as well. I would say yes. If you are a part of, if you are like obviously if you are giving this exam IIMB UG test, then definitely yes, you should be learning trigonometry. You should be learning calculus. I expect the paper to be more or less on the JEE main, not the JEE main exactly, but mathematics you could think a bit of towards JEE mains level, because anyways physics chemistry is not the part of this exam. So obviously you would be expecting trigonometry and calculus 11th 12th NCERT. See, when they mention the syllabus is 11th 12th NCERT, we all know mathematics 12th NCERT is most of like major portion is calculus. Similarly in 11th there are trigonometry, algebra and calculus makes the huge chunk of syllabus indeed. So yes, I would expect our paper to have good amount of algebra. I would expect our paper to have good amount of trigo and calculus. I would indeed expect one differential calculus at least and one integral calculus. Bare minimum is what I would expect this. Algebra, trigo, calculus are like karna hi karna hai. Must and should is what I feel for this paper, but more clarity will be received once we get the sample paper. Expecting these, but it could be a bit different as well. I'm not sure, but I'm expecting this to be the case. So in this particular question, our answer would be a plus 1 by b. If there is any doubt, please feel free to ask. Now let us deal with derivatives. So, okay. Now, what is a derivative? So derivative is basically a rate of change, but in a infinitesimally small interval. So let's say, if I say a person's speed is changed from 20 meter per second to 45 meter per second in 5 seconds. I would say in 5 seconds, this is the change. Then what is the rate of change? Here rate of change, we would say to be rate of change is difference, which is 45 minus 20 in speed occurred in 5 seconds interval. So rate of change will be 25 by 5, which is 5. Rate of change will be 5. But when I say this rate of change in speed in time, basically this is an acceleration. Rate of change is nothing but. So I took an example of meter speed and time. You could take in multiple cases. But here when I do this, I'm not worried exactly about each interval second. I mean, from 0th second to first second, or even infinitesimally small, like let's say half second or millisecond, whatever. So this derivative is basically, we will be checking the rate of change in a infinitesimally small interval, like let's say like okay, fine, this is a graph. Let's say one graph, some graph is there in this way. Let's say now this is a point and this is a point. Let's say this is at x equal to a, this is at a plus delta. Whenever I talk about the smaller addition or infinitesimally smaller addition, that is a plus delta. Delta is something like which is a very minute quantity of positive quantity which is greater than 0 and less than 1. So a and a plus delta, if I say, one sec, a and a plus delta, if I say, and this f of x is the function, right? This function could be of speed, acceleration, whatever you take, basically the one which you have to measure. So this point P and this is Q. I will write it as point P coordinates is what? Point P coordinates is nothing but at x equal to A, the value f of A. Similarly, point Q coordinates will be at A plus delta, the f will be f of A plus delta. This will be x comma y coordinates because x is this axis and y is this axis, y. This is x. 0 less than delta less than 1, the infinitesimally small value. See, there will be no big there will be no huge gap in between a and a plus delta. This is as close as possible to p. This p and q is as close as possible. That is a and a plus, not p and q exactly. I mean this point, this point. So this, let's say a, let's say this is point b. A and b are as close as possible with the lowest value of delta possible. Now the change of this PQ, the change in this PQ is what I am. From P to Q, what is the change? We define this change as change in value of y. Change in value of y, that is x comma y, right? The points which we talk about is always in the format of x comma y. So change in value of y divided by change in value of x. Change in value of x. But change in value of x is very low. That is change in value of x. In the previous example which we took, here the change in value of x is 5 sec. That is 5. In previous example, it is a huge quantity. 5 is not a smaller number. But whereas in the case of derivative is usually represented as dy by dx. That is dy by dx is nothing but change in value of y. Dy represents change in value of y. Dx represents change in value of x. But this dx is pretty small quantity. Dx is pretty small quantity. Sometimes you might have also seen delta y by delta x. So now you might get a doubt of what is the difference between dy, delta y, or dx and delta x. What is the change? Because delta x also refers to change in value of x. But usually in maths, when we use delta x, this is higher numbers. I mean to say, the change is not infinitesimally small. The change is some number like 1 or 2 or some good number, whereas dx could be as low as 0.001 also. This infinitesimally small value is what I am referring to. So in the case of derivative, we are discussing about dy by dx, or this can also be f dash of x, represented as f dash of x, f of x derivative. This is nothing but change in value of y by change in value of x. But we know value of y is changing from f of a to f of a plus delta when x is changing from a to a plus delta. So I will write change in y is nothing but final value f of a plus delta minus f of a is the initial value divided by final x value is a plus delta minus initial x value a. So this should be what? This is nothing but f of a plus delta minus f of a by, here a can be cancelled away, then I will get this delta. So f dash of x is nothing but f of a plus delta minus f of a by delta. So what is our intention behind doing this derivative, as I mentioned, is that to figure out the derivative at a smaller value change. That's a very minute value of change. So I would say indeed that minor value is nothing but this delta is approaching to 0. I know delta is definitely greater than 0, less than 1, but I am trying to make as low delta as possible to get my derivative value. That is for a minute change in x. Is this clear? The one which I am telling currently? There are people, please do respond. Please do understand the inherent concept meaning of what is a plus delta and what is delta. Why are we making it tending to 0? Why this derivative is defined in such a way is that this f dash of x is dy by dx is equal to this limit. I want this delta to tend to 0. I want this delta to tend to 0. That is as low as possible. F of a plus delta. And I am interested to compute change in value of y by change in value of x delta. This is what our literally the derivative term meaning. Probably in some textbooks you might have seen this delta represented as limit h tending to 0, and this is written as f of a plus h minus f of a by h. This is also the same thing. Instead of delta, they are just mentioning this h. Instead of delta, just they change the variable. That's it. There's no big difference between h and delta. So f of a plus h minus f of a by h, or f of a plus delta minus f of a by delta, limit delta tending to 0 or limit h tending to 0. Is this clear? Is this clear till now, guys? Please do respond. Because once you understand what is this, we will apply this. Basically, now we will go and apply this derivative limit to find the derivative of a particular function at a given value. Is this clear, guys? Then I'll move forward, please. I need the response now. Please, guys, do respond. All right. Then this is what the derivative meaning for the lowest change in value of x dy. So that's why we are making h or delta being tending to 0. Let us move forward. Yes. Example, find the derivative of sin x at x equal to 0. Find the derivative of sin x at x equal to 0. That is, we are asked to find, we are given the function f of x is sin x. We are asked to find derivative of f of x at 0. That is basically they are asked to find what is the value of f dash of x at x equal to 0. That is nothing but f dash of 0 value is what they are asking. So we know what is f dash of x. We know what is f dash of x, which is nothing but limit h tending to 0 f of x plus h minus f of x divided by h. This is what we have seen in the previous slide where I mentioned what is the derivative f of x plus delta minus f of x by delta. Delta tending to 0 or h tending to 0, both are same. Now, let us do this. So, we are interested into limit h tend to 0, f dash of x, which is f of x plus h, which should be sine of x plus h minus sin x by h. Sin x by h. What is sin a minus sin b? I have to, because this is 0 by 0 form, h is tending to 0, sin x minus x, sin x is 0, h is 0, so 0 by 0 I have to simplify it. So limit h tending to 0, sin a minus sin b. Sin a minus sin b is nothing but 2 cos a plus b by 2 sin a minus b by 2. That is 2 cos a plus b by 2 sin a minus b by 2. That is x plus h minus x by 2. Divided by h is already given. So this is nothing but I have applied this. If someone is getting doubt what is this sin a minus sin b. This is trigonometric identity, or let's say 2 cos a plus b by 2 sin a minus b by 2. Sin a minus b by 2. So this can be taken as, what is this? X and x will go away. I'll get sin h by 2 in the numerator and there is h in the denominator. So this h I would be interested to write h by 2 into 2. Because h can be written as 2 into h by 2. That should not make any issue to me. When I write it in this way, this 2 and 2 I would cancel it off. Then I would get limit h tending to 0 cos of 2x plus h by 2. Okay, I'll write it a bit bottom. This is interfering over there. Okay. So this is written as limit h tending to 0 cos of 2x plus h by 2 into, we have seen, sin h by 2 divided by h by 2. The reason why I am writing this is, now I'll say this is f of x and I'll say this as g of x. Algebra of limits, limit extending to 0 f of x into g of x is limit extending to 0 f of x into limit extending to 0 g of x. So this is limit extends to 0 cos of 2x plus h, which is nothing but h is 0. So cos of 2x by 2, which is cos x. Cos of 2x by 2 is what? Cos x. So cos x into, what is limit h tends to 0? Sin h by 2 by h by 2? That is nothing but 1. Sin x by x, limit extending to 0 as we discussed. So this is nothing but cos x. I got f dash of x is cos x. I got f dash of x is cos x. I got f dash of x is cos x. Now the question is, find the derivative of sin x at x equal to 0. So derivative of sin x is cos x. Then at x equal to 0, the answer should be cos 0, which is 1. The answer should be cos 0, which is 1. Is it clear, guys? Is this clear? Should be clear. So limit h tends to 0, sin of x plus h minus sin x by h is 2 cos a plus b by 2 sin a minus b by 2 divided by h, which is nothing but, again, we could use this simplification, we get directly it is cos x. So this is how we apply the thing which we learned, which is f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. F of x by h. Now let us take this example. Find the derivative of function f of x equal to 2x square plus 3x minus 5 at x equal to minus 1. 2x square plus 3x minus 5 at x equal to minus 1. How to find this derivative? How to find this derivative? As we have seen, f dash of x is nothing but limit h tending to 0 f of x plus h minus f of h divided by h. So we could apply the same thing. We get limit h tending to 0. What is f of x plus h? 2 into x plus h whole square plus 3x plus 3h, because 3 into x plus h, minus 5 minus h divided by h. So this should be nothing but limit h tending to 0. What is this? 2 into x plus h whole square can be written as 2x square plus 2h square plus 4xh plus 3x, plus 3x plus 2h, because 3h minus h is 2h, minus 5 divided by h. Now, why did we do this? We wanted at x equal to minus 1. So this is f dash of x. We wanted at x equal to minus 1. So let us see what's happening at x equal to minus 1. This is nothing but limit h tending to 0. At minus 1, this value is 2 plus 2h square. At minus 1, this is minus 4h. This is minus 3 plus 2h minus 5 by h. This is what our thing will going to be. This is nothing but 2 minus 3, which is minus 1 minus 5 minus 6. So I am getting limit h tending to 0, 2h square, minus 4h plus 2h is minus 2h. Now 2 minus 3 minus 1 minus 5 minus 6 divided by h. This is what we are getting. We are getting basically h is tending to 0, 2h square minus 2h minus 6, if I am not wrong, divided by h. Are we right, or did we make any mistake? Let me check. Why did we go wrong? F dash of derivative at minus 1. So limit h tends to 0 f of x plus h minus, sorry, why this is h? I made a mistake, na? No one is telling me. Come on, guys. I think you're not attentive. This is what f of x, na? I made a big mistake. This is f of x. So this is not h. This is f of x. What is f of x? 2x minus 2x square minus 3x plus 5. This is what here it comes out to be. So this should be what? 2x square plus 2h square plus 4xh plus 3x plus 3x. There is no more 2h. This is nothing but plus 3x minus 5 minus 2x square minus 3x plus 5. So what am I getting? I'll be getting 2x square going away. I should be getting 3x also going away. I should be getting minus 5 plus 5 also going away. Then I would be getting 2h square plus 4xh. I'll be getting I should be getting what? F dash of x is nothing but I am getting limit h tending to 0, 2h square plus 4xh by h. H can be taken common. This is nothing but limit h tending to 0. Now h can be cancelled off once. I would get 2h plus 4x divided by 1. Now I know this is f dash of x. H is tending to 0. So if h is tending to 0, 2h is 0 plus 4x. So if I am getting this particular value, f dash of x is 0 plus 4x. So f dash of minus 1 is nothing but minus 4. F dash of minus 1 is nothing but minus 4 because f dash of x is 0 plus 4x. F dash of minus 1 should be 0 minus 4. So where should we be going? Should be getting this value to be minus 4. 4x plus 3, right? F of x plus h minus f of x by h. 2 into x plus h whole square plus 3 into x plus h minus 5 minus 2x square minus 3x plus 5. So here it comes 2 into x square, 2x square plus 2h square plus 4hx plus 3x plus 3h. So there is one plus 3h here, na? Plus 3h minus 5 minus 2x square minus 6 plus 5. So here it should be plus 3h. Guys, this is a small mistakes which I am tending to do because of overtime I'm doing today. Plus 2h plus 4x plus 3 here. So this is what our f dash of x should be, which is nothing but basically 0 plus 4x plus 3. So this should be what? F dash of minus 1 should be minus 4 plus 3, which should be minus 1. Hope I'm clear enough. F dash of x is 4x plus 3. Just see, what did we do? Ultimately, we did f of x plus h minus f of x by h. F of x plus h minus f of x by h, which is nothing but substituting x with x plus h minus f of x divided by h. Just simplify properly, cancel the terms which are there. You will get this, making h, taking common and cancelling it off. You will get 2h plus 4x plus 3, h tending to 0. Then f dash of x is 4x plus 3. So f dash of minus 1 is minus 4 plus 3, which is minus 1. This answer should be what? Minus 1. Minus 1. I made mistakes. Please do follow it properly, guys. This is minus 1. Now let us see UV and U by V rule. I think we are 5, already 5, but please do hold for 10 to 15 minutes. We will finish our today's agenda where we do this UV rule and U by V rule and take 1-2 questions and then we can wind it up. So what is this UV rule and U by V rule is? This is basically algebra of derivatives similar to what we have seen in algebra of limits. Here we tend to deal with firstly what is d by dx of. First let us see addition and subtraction, that is f of x plus g of x derivative or f of x minus g of x. That is the reason I am writing plus or minus should be equal to d by dx of f of x plus or minus d by dx of g of x. D by dx of g of x. At the same time, now we will be seeing this product rule, which is also known as UV rule. We also call this as UV rule, which is nothing but basically when I say d by dx into f of x into g of x is nothing but we say g of x into d by dx of f of x plus f of x into d by dx of g of x. D by d of x of g of x. This is what UV rule is. That is nothing but u into v. F of x and g of x are u and v respectively. U is f of x, v is g of x. Then u into v whole differentiation, that is d by dx, is equal to u into v dash plus v into u dash. That is f into g differentiation is nothing but f into g differentiation plus g into f differentiation. uv dash is nothing but uv whole dash is uv whole differentiation is uv u into v differentiation plus v into u differentiation. That is what uv rule is, which is f of x into g of x is g of x into f dash of x, or this can be written as what? This can be written as simply f of x into g of x whole differentiation point is nothing but g of x into f dash of x plus f of x into g dash of x. This is what ultimately the uv rule meant. So this is uv rule, but there is one, this is a product, right? Similarly, there is for differentiation u by v rule. We call that as u by v rule. U by v rule for this, that is nothing but d by dx of f of x by g of x. F of x by g of x. This comes out to be basically, we do g of x into f dash of x minus f of x into g dash of x divided by g of x whole square. Divided by g of x whole square. So this is what can be written as basically u by v whole differentiation is nothing but v into u differentiated minus u into v differentiated divided by v square. V into u differentiated minus u into v differentiated divided by v square, which is nothing but the one which is written above. These are the product and different division rules which has to be remembered for solving the questions which you face in exam, definitely. And what is the proof of this particular thing is beyond your scope of exam, beyond your scope of 11th and 12th. That comes with, basically you will apply analogous theorem of limits over here. That would be very difficult for you people to currently grasp it because it takes some time and effort to understand that. But let us not get into it. Let us just stick to uv whole dash is u into v dash plus v into u dash. Similarly, u by v whole dash is v into u dash minus u into v dash divided by v square. Divided by v square. So this is for uv and u by v rule. This is for uv and u by v rule. Hope I'm clear, guys. This is for uv and u by v rule. Please do make a note in this note of this u by v and uv. That is f of x into g of x whole differentiation and f of x by g of x whole differentiation. So the theorem, this is a very important theorem in differentiation. F of x equal to x power n, derivative is n into x power n minus 1. F of x, that is nothing but d by dx of x power n is nothing but n into x power n minus 1 for every positive integer n. Now, having said that, it need not be only positive integer, guys. It could also be, need not be positive only. This could be even the negative integer. It could be fraction like minus 1 by 3 and everything. Here the theorem derivative of this for any positive integer n, that is true, but this also holds true for negative or fractions, need not be only integers as such. So how to prove this? Simple, the same thing which we have done. What is f dash of x? Limit h tends to 0. Again we do f of x plus h minus f of x divided by h, right? So for this point, what we are going to take up is that limit h tends to 0. What is f of x plus h? F of x plus h is x plus h whole power n. X plus h whole power n minus what is f of x? X power n divided by h. This is what we do here. Think people are following me up. If any doubts, please do ask. If you people are watching it, meanwhile, after few time, like taking a break in between and watching the replay of the video on YouTube, that should also be fine. That should also be pretty much fine. So this should be f dash of x equal to limit h tends to 0 x plus h whole power n minus x power n by h. How to deal with this? Here we will apply binomial theorem. I think we have already taken a session on binomial theorem. Cracku has taken a session if I'm not wrong. If not, please try to understand there is some binomial expansion x plus h whole power n. The binomial expansion is nothing but nc0 into x power 0 into h power n plus nc1 into x power 1 into h power n minus 1 plus nc2 into x square into h power n minus 2, and this so on. It goes till ncn into x power n into h power 0. This is what the binomial expansion is. X plus h whole power n is nc0 x h power n, nc1 into x power 1 into h power n minus 1, and so on. So when I do, now I'll do this. I'll apply this part onto here. I'll get limit h tending to 0. This entire thing minus x power n. This entire thing minus x power n, which is nothing but nc0 into h power n, because x power 0 is 1, plus nc1 into x into h power n minus 1, plus nc2 x square into h power n minus 2, and so on. Till what is ncn value? 1. 1 into x power n into h power 0 is also 1. This is x plus h whole power n, but we want x plus h whole power n minus x power n. So I would write here minus x power n divided by, we know that is h. So this last term x power n and minus x power n will cancel away. I would get this particular equation, which is by h na. So I can write this as what? This could be written as limit h tending to 0. When I write by h, I am getting nothing but nc0 into h power n by h is h power n minus 1 plus nc1 into x into what is h power n minus 1 by h, which is nothing but h power n minus 2, h power n minus 2, and so on. Like this, where do I get? See, here it is ncn into x power n, right? Oh, what happened? Right. So here it is ncn into x power n into h power 0. What is the preceding term? ncn minus 1, ncn minus 1 into what? X power n minus 1 into h is what the term is, but now by h is there. No, this is all we have done by h, so that also I'll be doing by h. So I'd be getting ncn minus 1 into x power n minus 1. I could remove this h. So this is what I'll be getting now. There is no h anymore. We removed one h in the numerator. What am I getting? If h is 0, I'll substitute h is 0. I'll get 0 plus 0 plus 0 plus all our h powers are there, where this will tend to 0, so on till here also there is h, but here I am getting what? H power 0. There is no h here. This is 1 na. This is 1. There is no h in the last term. Only in the last term there is no h. Rest of all the terms there is h, where h is tending to 0. So 0 plus 0 plus 0 into ncn minus 1 into x power n minus 1. What is ncn minus 1? Which is nothing but nc1, which is nothing but 1, because ncn minus 1 is 1. So n into x power n minus 1. This is what I'll be getting by using binomial expansion. Binomial expansion of x plus h whole power n. By applying this x plus h whole power n binomial expansion onto the derivative definition in the terms of limit, you could prove this theorem which says f of x equal to x power n, derivative is n into x power n minus 1. I just applied it throughout and cancel it off. Then you would be getting this. Then divided by h, h is taken common in the numerator to cancel the denominator. Then you will be getting this expression. Substituting h equal to 0, you get all the terms as 0 except one term, because all the rest of all the terms as having h in its term. 0 h value is tending to 0, so only one term which is there is no h, n into x power n minus 1. So this is a thing for theorem. Let us see. Oh, where is the slide? There should be a slide, no? Okay, let us solve this question. Here, we are asked to find the derivative of f of x equal to 1 by x at x equal to 2. Please do solve this. I'm really sorry guys, today the class is extending a lot. Did not expect it to be, but I took a lot of time to explain the limits and derivatives concepts, which forms the main base of calculus indeed. If someone is good at doing limits, no, he'll be good at doing entire calculus is what I feel. Differential calculus for sure. Integral calculus application comes on a different perspective altogether. So that should be dealt differently. But when it comes to differentiations or application of derivatives, if someone is good at limits, no, then they'll definitely do well in derivatives, undoubtedly, for sure. So spending time on limits makes sense to me more because that makes the base of the entire definitions. So find the derivative of f of x equal to 1 by x at x equal to 2. After 1 minute, after the timer ends, I mean to say, I would solve this. This is actually very pretty easy question where we already discussed what we have discussed. We have already discussed if f of x equal to x power n, then f dash of x is what? N into x power n minus 1. That's it. This is what you should apply here. And after finding the derivative you would apply, you should just substitute x equal to what is the value. Please solve it. As I already given the total hint or the total thing, so should be able to solve this. Let's wait for 30 seconds. Okay, derivative of f of x equal to 1 by x at x equal to 2. Let me solve this. It said f of x is 1 by x. Nah. So what is this 1 by x? This is nothing but x power minus 1. Because 1 by x is what? X power minus 1. X power 0 by x power 1, which is x power minus 1. So it is given n is minus 1 in this particular thing. Then f dash of x should be n into x power n minus 1. But I know n is minus 1. So minus 1 into x power minus 1, which is nothing but minus of x power minus 2. Minus of x power minus 2. This can be written as what? Minus 1 by x square. Minus sign is anyways there. X power minus 2 can be written as 1 by x square. So minus 1 by x square. So if f of x is 1 by x, then f dash of x is minus 1 by x square. F dash of x is minus 1 by x square. So at x equal to 2, f dash of 2 should be minus 1 by 2 square, which is nothing but minus 1 by 4. Minus 1 by 4, that is option D. The answer has to be option D, minus 1 by 4. The answer has to be option D, minus 1 by 4. Pretty simple. X power n into x power n minus 1. N is minus 1. So just minus 1 into x power n minus 1, which is minus 1 into x power minus 1, which is minus 1 by x square. So that is minus 1 by 4 at x equal to 2. Let us go to the next question. Find the derivative of this at x equal to 1. This is also fairly simple. But this has an application where you do where you use the algebra of derivatives which we discussed. Let the timer end. First you do it on yourself, then I will be doing this question. Okay, someone mentioned answer as option D. That's good to see. We will see what the answer exactly is, because even I should be solving that. Uh, 20 more seconds. Let's wait and then proceed with this question. Okay, there is the other person saying option B. Okay. The people who were texting now, are you clear enough on the concepts which we discussed before this question? I mean, let it be the derivative concept, the exemplar questions which we took, or even let's say the limits, the geometric proof of sin x less than x less than tan x. Please do let me know, the people who are solving currently, that uh, Simran Kaur and the other person, both of you, please let me know. So let me solve this question now. We are doing the derivative of 2 by x plus 1 minus x square by 3x minus 1 at x equal to 1. So now again, I would do this d by dx of what? F of x minus g of x is f dash of x minus g dash of x. This is algebra of derivatives. So I'll do that. 2 by x plus 1 derivative. Firstly, I should be doing what? I should be doing 2 by x plus 1 derivative. So d by dx of, what is that? 2 by x plus 1 minus d by dx of x square by 3x plus 1. X square by 3x, is it plus 1 or minus 1? Minus 1. Okay. So u by v rule, the first one also u by v, the second one also u by v. That should be what I should be doing. V into u dash. U dash is what? D by dx of 2. 2 is the constant. So the differentiation is 0. Constant is not changing. Change in value is not there. So 0 minus now 2 into differentiation of v. That is differentiation of x plus 1, which is 1 plus 0. X differentiation is 1 and 1 differentiation is 0. 1 plus 0 divided by v square, that is x plus 1 whole square. This is for first term. Similarly, what will be the case for second term? Minus of, again, 3x minus 1 into differentiation of x square, which is 2x, minus u into v dash, that is x square into v dash, which is 3x differentiation. 3x minus 1 differentiation is 3. What is d by dx of 3x minus 1, which is 3, right? Divided by 3x minus 1 whole square. 3x minus 1 whole square. See, what did we do here? We just did the value of d by dx of constant like 2 is 0, or the value of d by dx of what else we did, 3x minus 1 should be 3, because 3x differentiation is 3 whereas 1's differentiation is 0. This is what we have done. And we, even before doing this, the main thing which you have done is u by v differentiation, which is nothing but v into u differentiation minus u into v differentiation by v square. This is what we have done over right side. Okay, people said yes, sir. Okay, so this is nothing but x plus 1 into 0 is 0, minus 2 into 1 plus 0 is minus 2, divided by x plus 1 whole square. This is the first term. Whereas when I come to second term, this is 3x into 2x, which is 6x square minus 3x square. So 3x square minus 2x, minus of 3x square minus 2x on the numerator, divided by 3x minus 1 whole square. This is f dash of x. This is f dash of x. But the question is, find the derivative value at what value? At x equal to 1. At x equal to 1. So I would substitute at x equal to 1, f dash of x, or f dash of 1 is minus 2 by 2, 1 plus 1, 2 square 4, minus at x equal to 1, 3 minus 2, 1, at x equal to 1, 3 minus 1, 2, 2 square is again 4. So I'm getting minus 2 minus 1 in the numerator and denominator 4. So minus 3 by 4 is what I'm getting. F dash of 1 is minus 3 by 4. That is option B. Someone told option B, I guess, right? The rate RRG9. Good. Simran Kaur, please do check where did you go wrong? Why did you get D? The point, probably you might have done some mistake over this place where applying u by v rule might have gone wrong in your case. Probably you might have missed some squaring in the denominator, like x plus 1 whole square or 3x minus 1 whole square probably. So please do check where you went wrong. This would be the accurate solution for the given question. That is minus 2 by 4 minus 1 by 4, which is minus 3 by 4. Applying u by v separately for each particular term. Let us move forward. Trigonometric derivatives of sin x, tan x, cos x, and etc. So we will do for the, so that was for previous question, my bad. Okay. The previous question, yes, that is option D. That was minus 1 by 4. Yeah, that should be fine. Cool. So trigonometric derivative sin x, tan x, etc. Here we will see today I understand the session should have lasted longer, but this is bare minimum in the first session to do the calculus, limits, derivatives and everything. So just I'll take more hardly, let's say 10 minutes to finish. I'll deal with what are the derivatives of trigonometric like sin x, cos x, tan x, and I'll just take one example. Then I can wind it up. So what is sin x, tan x, etc. So first I'll deal with sin x. F of x is sin x. First I'll deal with f of x is sin x. I should be finding f dash x. So f dash x is equal to limit. We have already discussed this actually in the previous thing as an example, minus sin x by h. So this is sin a minus sin b, which is limit h tends to 0. 2 cos a plus b by 2, that is 2 cos 2x plus h by 2. Sin of a minus b by 2, which is sin h by 2. Because x plus h minus x is h by 2 divided by h. So this h can be written as h by 2 into 2. Now the reason for doing this is cancelling this 2, and h by 2 into sin h by 2, this is nothing but at h equal to 0 I get cos of 2x by 2 into limit h tends to 0 sin h by 2 by h by 2, sin h by 2 by h by 2. So this particular value is 1, as we mentioned previously. This is cos x because cos 2x by 2 into this value is 1. So basically derivative of sin x is nothing but cos x. Derivative of sin x is nothing but cos x. That is, I could write f dash of x here is equal to cos x. Because next time when you see derivative of sin x, you could use directly cos x instead of doing this all. Similarly, let us see what will happen for cos x as f of x. So again the same thing, I'll do limit h tends to 0 cos of x plus h minus cos x divided by h. This should be equal to what? Cos a minus cos b. See, cos a minus cos b should be 2 sin, or sorry, 2 cos, what do you get? You get precisely 2 sin a plus b by 2 cos a minus b by 2, cos a minus cos b, 2 cos, or 2 sin, no, 2 sin a plus b by 2 sin a minus b by 2, right? 2 sin a plus b by 2 sin a minus b by 2. Or let me check what is the thing of cos a minus cos b. Even I'll usually forget this trigonometric part, because there is some negative sign in one. See, you get sin a plus sin b is 2 sin a plus b by 2 cos a minus b by 2. Cos a sin a minus sin b is 2 cos a plus b by 2 sin a minus b by 2. Cos a plus cos b would be 2 sin a plus b by 2 sin a minus b by 2. Whereas cos a minus cos b would be minus 2 sin of a plus b by 2 sin of a minus b by 2, if I am not wrong. But before dealing, I will just check if I am proceeding with the right expansion of cos a minus cos b. Cos a minus cos b is nothing but minus 2 sin of a plus b by 2 sin of a minus b by 2. A minus b by 2. This is what cos a minus cos b is. This is what cos a minus cos b is. So if this is cos a minus cos b, one sec. if this is cos A minus cos B, then I'll apply the same thing over here. That would be limit h tending to 0. What is, this is minus 2 sine A plus B by 2 is x plus h plus x, that is 2x plus h by 2, into sine of A minus B by 2 is x plus h minus x, which is h by 2. But this divided by h is anyways there. H is anyways there. This is just the formula part. So h will be here. I could write this as again h by 2 into 2, so that 2 I can cancel it off. I'll get minus 1 times of, what is h tending to 0? Sine 2x by 2, which is sine x, minus 1 into sine x into limit h tending to 0, sine h by 2 by h by 2. Sine h by 2 by h by 2. What is this particular value? This particular value is 1. So minus sine x is my answer. Minus sine x is my answer. So this thing, I would say, if f of x is cos x, f dash of x is minus sine x. Minus sine x. Minus sine x. Similarly, let's do for tan, because usually it is sufficient to do for sine, cos, tan. Cot will be similar to tan, it would be minus cosecant square x. But let us, for today's session, let us do these three. The rest of the things, that's like an homework for you. You should be applying and doing it on yourself. So limit h tending to 0, tan of x plus h minus tan x divided by h. So this can be written as what? Limit h tending to 0, sine of x plus h by cos of x plus h minus sin x by cos x, minus sin x by cos x, this whole divided by h. This can also be written as limit h tending to 0, I get sine of x plus h into cos x minus sin x into cos of x plus h, right? Sin x plus h into cos x minus sin x into cos of x plus h by h into this cos of x plus h into cos x. What is the numerator? Sin A cos B minus cos A sin B. Sin A cos B minus sin A cos B. Sorry, sin A cos B minus cos A sin B. Cos A sin B, no? Cos A sin B. What is this? This is nothing but sin of A minus B. Sin of A minus B. What is sin of A minus B? Sin A cos B minus cos A sin B. So if you see numerator, A is x plus h, B is x, sin A cos B minus cos A sin B. So this particular thing, I would be interested to write it as limit h tending to 0, sin of A minus B, which is nothing but sin of x plus h minus x divided by h into cos of x plus h, as what it was there initially, into cos x. So x will go away. This is again sin h by h I am getting. Limit h tends to 0, sin h by h is 1 into limit h tends to 0, 1 by cos x plus h into cos x. Cos of x plus h into cos x. What is this value? This should be equal to what? 1 into, if h is 0, this is cos x, this is cos x, which is cos square x. 1 by cos square x is also known as secant square x, because 1 by cos x is secant x. So 1 by cos square x is nothing but secant square x. So I would say differentiation of tan x is secant square x, that is sin A cos B minus cos A sin B, and we will be end up getting this particular limit value. Am I clear? I think I'm clear. We have done 3 trigonometrics now. One is sin x. We have got to see that f dash of, if f of x is sin x, f dash of x is cos x. For cos x, the differentiation would be minus sin x. For tan x, the differentiation would be secant square x. These 3 things we have seen. And you could do for anything. You could do for secant x, you could do for cosecant x. Similarly, you could do it for cot x, and that can be done as a homework for you. By applying this thing, you should be end up getting the same as what the original things would be. So this is the final slide for today, the example thing. Find the derivative of x plus cos x by tan x. So let me solve this. How to do this derivative? Derivative d by dx of x plus cos x into tan x. I would be doing what? I would be doing u by v rule. What is u by v rule? It is v into u dash minus u into v dash divided by v square. So I'll be applying the same thing now. V is tan x, so tan x into what is the differentiation of x plus cos x? X plus cos x differentiation minus u is what? X plus cos x into differentiation of tan x. Differentiation is written as dash. I mean x plus cos x per dash, or this is the way of representing it, by tan square x, because v square is tan square x. So what is this? This is nothing but tan x into what is x plus cos x differentiation? 1 minus sin x, because x differentiation is 1, cos x differentiation is minus sin x, minus of x plus cos x into, I would be getting, what is tan x differentiation? As we have just seen previously, it is secant square x is the differentiation of tan x divided by tan square x divided by tan square x. This will be the derivative. This will be the derivative. You need not simplify it further. This should be pretty much fine. They did not ask us to do find the numerical value at some x equal to 90 or 45. They didn't ask so. It was just an example taken to apply this trigonometric thing of differentiation, including with u by v rule. Including with we have used two things over here: u by v rule differentiation, and we also used how to deal with x plus cos x differentiation and tan x differentiation, so on. So this will be my answer to this particular thing. For today, this is what our session is of. We have covered pretty much limits and derivatives. We did deal with things which usually exam point of view. I think you could expect one question on limits where they will definitely combine sin x or cos x, probably sin x most often. So you would be tend to apply sin x by x for sure. Sin x by e power x or sin x by x, or let's say sandwich theorem, where you say f of x, g of x, h of x, and you will say this both are getting to the same limit. So obviously g of x should also getting to the same limit. That is what one question which one of your peer has posted on the channel, one question photo. There also we apply the same thing. So you should be clear about these things where usually you apply limits, so that I'm pretty sure question will be there, one or two in your original exam. So derivative, also there will be a question where you will apply derivative points of u by v. U by v rule ke upar one question I'm definitely expecting, and that there is a pretty good chance that question will be in combination with trigonometry. Instead of giving a simple thing, there's a pretty good chance. So I hope this is clear. We will see when can we schedule the calculus 2. One thing before I say this, as per our plan of action, we should be taking calculus 2 tomorrow, that is on Sunday. We are trying to do that for sure from 3 to 4:30. But to the best of my understanding, as per the experience what I got from today, to do it on a single stretch, as it took 2.5 hours for us today, more or less 3 to 5:30. So that will be a long session. This is a long session, and continuity differentiability will also take this much amount of time, or even a bit more if I have to cover it comprehensively and properly. So probably we could, there is a chance, but I'm not sure yet. We could cover a bit less tomorrow, or we could change the topic for tomorrow's session, and we could take calculus 2 once after, in a multiple sessions instead of doing it on a single stretch, because I'm pretty sure people will feel tired if they do it on the single stretch. I'm pretty sure their grasping will go low if I have to discuss many topics at one go. So we should be taking time which that topic demands. So let me figure out how to proceed with the next further topics. Meanwhile, please keep practicing. Thanks for tuning in. Great to see you all.